So, guys, 2023 is what called is a return of what El Nino after the La Nina phase or the normal phase. You heard this or not? So, what was the last 3 years we experienced? Normal rains or above normal rains in India? Last all 3 years, like 20, 21, 22, right? Either we normal rains or above normal rains in the southwest monsoon. Correct. But this time, 2023 is been saying that it will be which year? El Lino year. El Lino. So the questions might be on this. Please remember. So I will be discussing little bit basics on El Lino. What is El Lino? So El Lino. So El Nino is a part of southern oscillation. Part of what called which oscillation? INSO or this thing. If you heard this concept, let me write actually for you. I'm using this white point, white marker. So few questions might be there. So how El Nino arise? What is El Nino? So how or how it is related to INSO effect? How related to what? Related to which effect? El Nino, southern oscillation effect. Okay. Now, so what is the impact on India? Impact of El Nino, especially on Indian on India. So this is the three things, or in the world too, in the world. So these are the few specific and very important questions arise out of this. El Nino, so so if you observing Southern Pacific Ocean, which ocean? Southern Pacific Ocean. I will not be just explaining in fast manner. I'm going slowly. You can write also along with me, guys. So it's a part of Southern Pacific what? Ocean. So Southern Pacific Ocean. Southern Pacific Ocean, eastern and western part does not have similar kind of surface temperature. So eastern western part, eastern and western part has what? As sea, so effect in terms of temperature. In terms of what? Temperature. If the east is warm, west will be cool and vice versa. Okay. This calls Southern Pacific Ocean at equatorial region, especially at which region? At equatorial regions of. So this was first observed by Gilbert Walker. This was observed by whom? Gilbert Walker, and that's what this concept is also called as Walker cycle 2. Gilbert Walker observed this, and that's what this concept is linked with what called sea-air interaction. He observed what called sea-air is not separate, they are linked actually, and this is called sea-air interaction. That interaction is a part of what called sorry, so understand this word. So Gilbert Walker observed the interaction between the sea and air, and this interaction is called teleconnection. He observed this interaction by observing which part? Equatorial region of Southern Pacific Ocean. He said this called Southern Ocean, like the water bodies. Okay, water bodies is the biggest source of what? Water bodies are the biggest source of trapping the solar heat energies. If you are observing this, so if you know on the world, heat energy difference existing globally latitudinally. Suppose this is the globe. So all atmospheric cycle comes out because of what? All atmospheric cycle is because of heat comes from whom? Sunlight. Sunlight becomes the source of heat energy, and this up to tropics, it become a tropical regions, isn't it not? And this become a temperate regions, and then become what called frigid regions. If you look at this way, so up 0 to 30 is one atmospheric cycle operate, 30 to 60 another cycle operates, 60 to 90. So this sunlight is falling on latitude. So there exists north-south atmospheric cycle, which you already know, called as what? Hadley cell in the tropical areas, Ferrel cell in what called mid-latitude temperate areas, or the polar cell in the higher latitude. And these cycles are operating in which direction? North, south direction. And this arises due to what called differential heating of the latitudes. Tropical is the hot areas. Polar region is what? The frigid region, colder region, and this is a temperate area, is a mid temperature. So that's what this comes out. That's what you have 3 cells atmospheric. So similarly, Gilbert Walker thought what? Apart from latitudinal energy storage of sunlight, latitudinal energy difference, there is also energy difference possible between land and what called? Energy difference between whom? Land and what? See, now if there are 2 things are there, one is a land part, another is water part. This is a sea land water part. This is a land part. Okay. So when sunlight is falling on both the aspect, who get be heated up more? Come on, think logically, we'll get your answers here. Google, I'm just going through a chat, you can say this. So how this Gilbert Walker come to this kind of logics? Right. Amount of heat energy is falling in both from sun, from both land and the sea. Who will be trapping more solar energy? Come on, look logically. Who will be trapping more? Please listen to the question very carefully. When sunlight is falling on the land part and sea part, who will be absorbing more sunlight? Answer is ocean, right? Answer is water is the largest heat absorption. And this is the logic. He said that ocean stored what? Ocean hold more energy. Ocean hold more what? More solar energy than what? Than land or continent. So now this is happening every day, every month, every year by year, from billions of years, this process are happening. So oceans should be getting heated up more and compared to what called land masses. But it is not happening. There must be something which make the ocean temperatures in equilibrium actually. Okay, maintain the temperature. And this process is what called sea-air interaction. So the sea is able to maintain temperature, heat energy by transferring their heat content to a home, to what called atmosphere. So that produces a situation. So he started observing what oceans on the earth actually. So which is the largest reservoir of heat energy? Which ocean? Come on, think logically. If your logics are right, you can give your answer. I'm explaining this. The rest of the things I was going fast. Is the technical. So which ocean is the biggest trapping the solar energy? Answer is Pacific, right? Pacific Ocean. And which part of Pacific is storing more, the Northern Pacific or Southern Pacific? Which is the bigger here? Right. So that was the biggest case study started at the Southern Pacific Ocean. So the Southern Pacific Ocean, bacho. So Southern Pacific Ocean become the case study. Southern Pacific Ocean become what called? Become case study. So it starts studying that. So what he observed, eastern and western part of Southern Pacific Ocean does not have same temperatures. Okay, so he just, if you're observing this part around equator, this is an equator, like this is an equator part, and this is okay, the South American part. So this is a South American part. So what he's observing around equator in the South Pacific Ocean, eastern and western part does not have same temperature. He observed this around South American coast. This water is what? Generally remain what? Cold. On the Australian coast or the Indonesian waters here, what is the temperature condition? He observed what? Relatively what? Warm. This is a general observation. So such kind of observation is everywhere too. So, and that's concept he only call what? Which oscillation? Southern oscillation. Sometime warm and cold condition get interchanged. Okay, and why the cold waters are present? He said there is some current here called cold. Which current? Peru current is maintaining cold waters on the South American coast, and the East Australia is having what? Warm current. So the cold current, Peru is a which current? Cold current arise due to upwelling process. Which process? All cold current is due to what call? Which process? Upwelling process. And all warm current is due to which process? Downwelling. Please keep these facts into account. That was his observation, that these kind of situation are existing. So he called this concept as what called? A southern oscillation. Now he said this concept, he was thinking sometimes the cold water will become what? Warm water, or replacement of cold current by which current? Warm current, and this warm current is replaced by what? Cold current. Warm water is replaced by what? Interchange is possible. That's what this word he has used called what? Southern what? Oscillation. That means what is the oscillation? That eastern and western part of Pacific, the temperatures are not same. So that's why in the beginning, what I said, it is what? Eastern and western part of the Pacific Ocean of the southern part around equator has seesaw effect in terms of temperature. Cold on east side and the warm on west, and vice versa is there. And so he observed this oscillation. When he observed the cold current is replaced by warm current. So this current is called as what? El Nino current. So El Nino current is which current? Warm current observed on what? The South American coast. So that's what he came to the concept of El Nino linking with southern oscillation. That's what this concept is called what? INSO effect. Which effect called? INSO effect. I'm giving very brief actually. What is the full form of INSO? Anyone? What is the INSO full form, bachon? I'm just reading a comment. Full form EN for El Nino or SO for southern oscillation. Absolutely correct. Absolutely correct. So INSO is the two things. Like INSO observing three phase, like the southern Pacific Ocean around equator, enter into three situations. Three situation. If long-term average is maintained, we call what? Normal INSO situation. If INSO become what call more than the same direction, we call what? Positive INSO. Sometime your INSO cycle get reversed or weak, we call as what? That situation called what? Negative. So long-term studies also observe that there are three situations possible linking El Nino and southern oscillation. Normal INSO effect, positive INSO effect, and what called? Negative INSO effect. What happened in the normal INSO? So all the phases approximately stay for what called? How much time? Around 18 months period, like 1.5 years period. So 1.5 months. So that means every phase get repeated after, on an average, after how much time? Come on, 3 to what? 7 years. So when this cycle is fast, after every 3 years, a same phase will goes on. Or if the cycle is very slow, it will take how many years? Come on. The cycle is very slow. Look logically. If the cycle is very fast, one year every phase get over. If the cycle is slow, the cycle will reappear after a gap of 7 years. That's the point is. So sometimes your INSO cycles are stronger, sometimes INSO cycles are weaker. On average, around 18 months, 1.5 years are there. If it's a very slow, it's 2 years, like 2 years. 7th year will be repeated, same situation. So we said El Nino reoccurred after a gap of how many years? So what is the answer in that on an average? Come on. After 3 to 7. So it will be anything, very 3 to what? 7 years in between anything. So no exact value, but anywhere between 3 to 7 Yes, that's your answer. Every phase will repeat it after phase. This is one prelims question. So what is normal INSO means? Like when normal INSO is there, your weather situation in the world will be also remain what? Normal. So normal INSO is impact is normal weather conditions. Okay, normal weather condition. Positive INSO means what call? Your normal weather conditions in the world remain what? Speeded up, accelerated weather conditions in the world. Okay. Why? Because your Walker cycle get speeded up in the same direction. Negative means what call? Your normal weather conditions will be not there. It will be behavior of the weather condition will be what? Below normal. So below, so in a negative INSO, your all the weather condition in the world behavior will be below what? Normal. Accelerated means what? Above normal. I'm asking to you. So when India experienced monsoon above normal, is that positive INSO or negative INSO? Come on, let's read your chat again. Yeah, positive INSO, absolutely. When India experienced monsoon above normal, it means positive INSO called La Nina effect, correct. When the Indian monsoon behavior is below the normal, drought occurs. That reason is what called? The reason is called negative INSO or called El Nino effect. So we are writing here. So positive INSO, this is called La Nina effect. And the negative INSO is called what? El Nino effect. So all this is being considered actually. So in case of a normal INSO, what happened? In case of normal INSO, what happened? So this is a simple situation you try to think. Okay, this is a normal situation. Now, so normal situation, this is southern equatorial region, and this is your South American coast. Normally, what happened on South, this is Southern Pacific Ocean, okay? Southern Pacific Ocean. On the South American coast, what is the situation, Bachu? Normally, there is an upwelling phenomena is taking place. Because of the upwelling on South American coast of Peru, so your cold waters are on the surface. On this, the cold waters are maintained. So while on the Australian coast, what is the situation? East Australia. So the downwelling process is operating here. And because of downwelling on the surface, which waters get piled up on the Indonesia, East Australia, warm water spot. So now the sea air interaction take place. So the cold waters is maintained by cold upwelling Peru current here or Humboldt current. Okay, and because of that, high pressure is maintained on this side. And this side will be because of warm waters, what kind of pressures will be maintained? Warm. So now sea air interaction is happening. Like this is sea. Now the condition energy is transferred from sea to what? Air. Come on, warm waters will maintain what kind of uh, pressures, atmospheric pressures? Low pressure. This is a very simple concept. You everyone knows it. And because of that, when air start moving from where to where? High pressure to what? Low pressure. From South American side from American side to the Asian side start moving. So this side will maintain what? This offshore wind, and this will be on shore wind, which will be a cloudy. Come on, low pressure will be rise of air, cloud formation, and what? Rainfall would be. And this will be what called? Drought affected. So the American coast will be what? Drought affected generally. And the Asian and the East Australia will be what called? Rainy weather. So monsoons will be remain what? Normal. So you can understand this is a normal situation because of directions. What happened in the positive end? So what happened during what? La Lina. During La Lina, if you observe, which phase called with which effect? During what called La Lina effect. What is observing? This is also called cold phase of what? Of INSO, El Nino southern oscillation. What happens here? So the warm waters of Australia become more warm. Okay, this become what called this become what called more warmer than the normal condition. And this part of the Peru coast, cold waters are there and become what called more what colder water. So the difference between colder warmer waters will be more. And what happened to this Walker cycle, which is moving in atmosphere from high pressure to what? Low pressures here. So what happened to this? What happened to this high to low? The wind here will become what called? Come on, this Walker wind will be what? Stronger or weaker, which is moving from east to the west. Come on, seeing the comment here, chat. No. Now the high become more high and the low pressure become low, more low. What happened to the Walker wind, which is moving from east to west, from American side to this, become stronger, right? So Walker wind become stronger. When Walker wind are stronger, so cloud formation on this side will be what? More. Asian monsoon will be what? More than normal and heavy rainfall. So this is a situation for what called heavy rainfall occurrence. So monsoon will be what called? Monsoonal climate will be what? So Asian monsoonal climate behavior will be what? Above normal. Okay, will be above what? Asian monsoon, Australian monsoon, Indian monsoon, any monsoonal climate will be above normal. When the rainfall is above normal, it will come early, it go late, breaks will be less, amount of rainfall will be torrential, and this resulting into what called? Which situation? Monsoonal what? Floods actually in these regions. So Asian monsoonal floods, American monsoonal floods, okay, Australian monsoonal flood, Indian monsoonal climate. So monsoonal floods are explained by which event? Answer is what? La Nina effect. So La Nina is what called actually a warmer current on this side. Okay, this will be a more warmer current. This is called La Nina current. So La Nina is a Spanish word actually. If you look at that, which word? Spanish word means what? Little Nina, girl or a boy? Spanish word mean what? La Nina generally is for no. Nina is a girl. El Nino is a boy. Okay. So La Nina is a Spanish word which means little girl is also warm current actually. It's actually is a which current? Warm current of East Australia become more warmer. That's a situation. A cold current of this Peru current become more colder. That's a situation. Okay. Extreme drought on right. Like Atacama Desert or Peru coast is already dry generally. So it become more dry actually. American coast of Pacific will be what? Experiencing what? Already dry. So having what? In the deserts become more extreme drought affected, more dry. That's the only thing. So forest fires will be what? Come on. Forest fire on the Pacific coast will be what? More. That's all logical will comes out. Okay. What is second situation? What is second situation? So we have done two parts, bachcho. What is second situation called? Il, what is second situation we call this? The next called negative INSO effect. Negative INSO is also called what? El Nino effect. El Nino effect arise when situation get reversed. So this Peru coast, the upwelling and downwelling get reversed. Now this situation, no, what? How does it happen? So there is a counter equatorial current which move from eastward direction like this. So sometime what happened? It bent actually on the Peru equator onward. Is bent. So whenever this warm counter equatorial current, sometime what will happen? It bent a lot actually. And because of why does it happen? So sometimes this trade winds become weaker. So this is a trade wind, is an offshore trade wind become what called weak. Offshore trade wind is moving on Ecuador and Peru. Trade wind is weak, become weaker. So it is moving from land to sea, it's become weak. So sometimes it allow warmer counter equatorial current to reach to the Peru Ecuador coast. So piling of which waters will start taking place? Piling of what? warm waters from equator on this side is there. So whenever warm waters are more piling, so the upwelling process get what? Stopped. So the cold Peru current is now replaced by what called warm current here. And that's what is called as which phase? Warm phase of what? ENSO. So here warm waters are start piling up actually, this side on the Peru side. And this is extending now in this direction, warm water with the time. So around 1.5 years, this process will continue like this. So there is no role of cold current. Now what will happen? Your oceanic water circulation will replace now upwelling location becoming downwelling, producing warm current. This warm current is only known as what? El Nino current. Generally first time observed during the December month, December, January, it has been observed. Okay. This warm current or El Nino current is observed during which time? El Nino is a warm current. El Nino is a warm current generally observed in the month of what? December and January months. So it remains a longer period of time. So the meaning of El Nino is what called? Little boy or Christ child. During the Christmas period, it's emerged actually. And because of this, what happened? Situation get reversed. Upwelling will become downwelling, and downwelling will become what? Upwelling. So the East Australia is experiencing what? Upwelling process. So as a result, cold water start rising and getting piled up here. And this side location will be what? Which waters? Warm water. So now cold waters will maintain high pressure here and low pressures on what called? On this side. So what happened to the PGF now, Bachu? What happened to the pressure gradient force or the Walker wind directions or Walker cycle? No, coral beach, I'm not talking about. Just what is I'm asking, answer that. Right. Walker winds become weaker. Right. Walker wind not, it's get reversed. And the normal Walker cycles also get reversed. So right. Walker wind is now moving from high pressure to low pressure, that from Asian side to what? American side. So where will be more cloud formation and more rainfall? Come on. More cloud formation, more rainfall will be on which coast? South American coast of both North American, South American coast will have more rainfall, correct. And what happened to this Asian coastline will be what? Asian coastline of Pacific Indian Ocean will be drought affected, right? It remained dry. So this is the reason for what? Dryness here. Dry weather condition. So monsoon get failed actually. Monsoonal rain got failed because of this situation. So delay in the monsoon will be there. Okay, it's not coming on time. So and it's become weaker monsoon, southwest monsoon of India become weak. And so early withdrawal, longer breaks, and finally the southwest monsoon cycle get. And this is the reason for what? Droughts of Asian weather condition. So what will happen on these Peru coast or South American coast that experience good rain actually? And this right, that rain is in the deserts. And the rain in the desert will cause but what? Come on, like desert does not have a drainage system. No line where to it do flooding, right? And flash flooding. That is a special type of flooding called what? Flash flooding in the inland drainage systems caused. Like Californian coast of North America or the Atacama deserts of Peru, North Chile, all has experienced flash flooding even. That's the situation. What happened to the fish identified on the Peru coast? Largest exporter of fish, marine fishes, Peru. Because of cold current, fish is more found on this Peru coast and the more export. What happened due to the warm current, El Nino current here? Come on, look logically. Cold waters are good for the fishing. Now warm waters are there. What happened? So now, like the fish died actually. Less fish export, and they are known for what? One export from the Peru, apart from this fertilizer called as which fertilizer export from Peru, which has also been depleted. This is an organic fertilizer, nitrogen fertilizers, guano fertilizers. Guano, you heard of guano, guys? So that means from economy of Peru get paralyzed due to the presence of warm current. Like the Peru current, like one called guano is a bird. And that is the excreta releases the waste which is collected and sold as what called guano, GUAN, guano fertilizers in the world as one of the organic type of fertilizers, which is organic type, exported from Peru, is that depleted. Even one special type of fish is found in Peru called as what? Anchovies, which also been exported. The largest exporter of anchovies fish in the world is Peru, or any kind of marine fish is Peru in the world. That is fish export get reduced. So export of this, export from Peru. So various type of economic things have been asked. I hope you got this topic clear, everyone.